will often be shown equations that look like this. Each of them has two letters, and both letters are only to the power of 1. These are called linear equations. These equations are common in the real world, as they represent things like cruising at a constant speed or business earnings for a number of items sold. These equations can be graphed. Let's see how. We can start by looking at the first example. Graph the equation y equals 3x plus 2. So what is the question asking? Why are we asked to graph? Why not just solve it like we did in the other algebra video? In the other video, we solved the equation by getting the unknown, the letter, on one side of the equal sign and everything else on the other side. But we can't do that in this situation because there are two unknowns. What happens if we try and solve it? Is x equals 1 a possible solution? Let's see. If we substitute x equals 1 into the equation, we obtain y equals 3 times 1 plus 2, which equals 5. So, yes, it is. Now, can x equals 0 be a solution? Yes. If x equals 0, then y equals 3 times 0 plus 2, which is 2. Another solution. How about x equals 2? Yes, y equals 3 times 2 plus 2, which equals 8. We can set x to be any number we want, and for each value of x, there is a corresponding value y for which xy is a solution to the equation. Okay, so x can be anything. If x equals 1, then y equals 5, and we have the point 1, 5. If x equals 2, then y equals 8, and then we have 2, 8, and so on. So how can we graph it? Let's try graphing all the points. This is our plan. We can plot these 3 points in the Cartesian plane. X equals 1, y equals 5, x equals 2, y equals 8, and x equals 0, y equals 2. Interesting. All these points lie on a straight line. In fact, linear equations always produce a straight line, hence their name, linear. So really, to graph a linear equation, we just need to find 2 points that are a solution to the equation, any 2 points, and draw a line through them. This line represents all the possible solutions to this equation. Is our answer reasonable? If you have only used 2 points to plot a line, a simple way to check if your graph is correct is to pick a new solution to the equation and check that it is also on the line. Let's try x equals minus 1. In that case, y also equals minus 1. So our point is x equals minus 1, y equals minus 1. This point lies on our line, so that's a good indication that our answer is correct. Linear graphs can represent a lot of different situations, so you'll regularly come across them. Try graphing the other 2 examples in this video. The solutions are in the worksheet.